Good evening, students. Welcome to one more session of your World of Chemistry, that is a trick series. Right. Basically, I've already kept in the community tab. I'll be giving the exceptions as well as tricks in inorganic chemistry. So here I have picked up almost top 25 tricks in inorganic chemistry. So earlier I did a video with 50 tricks. So 50 tricks was a super hit series, if I have to tell you. All the 50 tricks of inorganic chemistry, students have used it in the exam and they said, ma'am, we could really utilize those tricks. So please watch that. This is a super hit video which I did. It is kept in the playlist. Please check it. So today we'll be learning, or we'll be seeing top 25 tricks in this video, right, students? So thank you for making this 50 trick a wonderful hit. Now today we'll be seeing the top 25 tricks. So added to this is the 25. Total number of 75 perfect tricks you should learn in inorganic chemistry for applying it in the exam. Let's see. So here, let me start with the top 25 tricks. Let's start off. Please take your pen and your book and then we'll start off with the series. Right. Please, I request you all to share it so that once knowledge is shared, it will be useful to all your friends, isn't it, students? Yes. So after erasing the board, the first important trick. So I'll be giving the examples also. Today we'll be seeing with the examples all the tricks which will be useful. Right. So when I have to speak about the first trick, remember, I'm giving the statement as well as the example, right? So here you need to remember the first statement is as positive oxidation state. Okay, positive oxidation state. So what is positive oxidation state? Let us see. First write the reason and then understand. As the positive oxidation state increases, if this increases, remember the radius decreases. So what is important here is the positive oxidation state increases, radius decreases. This is what you need to remember. How? For example, if I have to take this one, suppose manganese is here, Mn plus 2 is here, Mn plus 3 is here. Let us assume. Now I said positive oxidation state. So positive oxidation state, this is 0, this is plus 2, this is plus 3. So the positive oxidation state is increasing. So which will be having less radius? See here, the positive oxidation state is more, means the radius of this will be less. So how will be the order? Mn will have greater radius than Mn plus 2, which will have greater radius than Mn plus 3. So as a positive state increases, radius decreases. So this is the order of the radius of the charges. Now let us write in a different way. Right, now I'm taking out the first one. Hope you would have noted this. So first thing you need to remember, positive oxidation state increases means compulsory the radius decreases. Right, students, this is clear. Let us learn the next trick. So let me erase the first trick and go with the second trick. Right. So in the second important trick of inorganic chemistry, let us write in terms of negative. As negative oxidation state increases, remember, radius decreases. How is this possible? Let's see. Suppose you have oxygen, you have O minus, you have O minus 2. Now if I have to write the radius, what is the order of the radius? O, this one will be lesser than O minus, which will be lesser than O minus 2. What is the reason? Just now we have written as a negative oxidation state increases. Negative oxidation state increases means the radius will be very less for the higher negative values. For the negative oxidation state, whichever has more, radius will be less for that. Okay, so this is the second trick. Let us take one more trick and see with an example. So in the third trick which I have to write, suppose there is an isoelectronic species. Okay, so in isoelectronic species, let us write that in an isoelectronic species. Okay, in isoelectronic species, what happens? As an atomic number increases. So let me tell you, as an atomic number increases, radius decreases. Remember, this is the third trick. Radius decreases. Why this decreases? Because of the reason is because of Z effective increases. So effective nuclear charge increases means automatically the radius decreases. So remember, atomic number increases, important. Next comes the radius decreases, important, because it keeps on entering into the same shell, right? And that too, Z effective has more, means automatically the radius becomes less, right? So let us see one more important of Z effective, because I have written this. I'll erase the third trick and give you the fourth trick. So in the fourth trick, you need to remember now, if Z effective, if you are speaking, if a question is given on Z effective, always remember ionization energy. IE means I dot E is nothing but ionization energy, isn't it, students? Yes. So the ionization energy is directly related to Z effective. Okay, if the Z effective increases, ionization energy I need to apply also will be more, right? Suppose if I have to speak in terms of atomic size, remember on the ionization energy in the atomic size. Ionization energy is indirectly related to atomic size. Remember this. So, with the atomic size is this one higher. The bigger atomic size is there, I require less energy to pull out the electron. Simple as that, isn't it? Yes. So this is in terms of the Z effective and ionization energy in atomic size, right? Next important thing, if I have to speak in terms of electronegativity, right, I'll write that as a fifth trick, which is very important for you. In the fifth trick, electronegativity is directly related to Z effective, the ability to attract the electron. So this is directly related. And if I have to speak in terms of atomic size, it is inversely related to your atomic size. Remember this. So electronegativity, this is a concept. You can apply the electronegativity question if they ask you in the exam. You can directly apply this concept and answer that particular trend. Okay, right. Now suppose if I have to speak about oxidation state and electronegativity, let's see that. So I'll take out this fifth one and I'll write the sixth one for you all. Just see, in the sixth one, suppose as positive oxidation state. So positive oxidation state increases. In the exam they have given you positive oxidation state, like for example let us say, okay, let me take one example, KMnO4. So KMnO4 they have given you and MnO2 they have given you. Now see here, as a positive oxidation state increases, that means I need to write the oxidation state here. If I have to calculate the oxidation state of manganese is +7 in this case. Here the oxidation state, oxygen is -2, 2 2s are -2, 2 2s are 4, and this becomes +4. So here positive oxidation state is for which one more? For Mn in KMnO4 is more, isn't it? So the positive oxidation state increases. Remember, the electronegativity also increases. So as a positive oxidation state increases, what should I remember? Electronegativity also increases. So this is the important trick you need to remember. So whenever you see the positive oxidation state is increasing, so in these two, which one has more electronegativity? So this one, because the positive oxidation state is +7. Here the positive oxidation state is +4. Okay, let us write one more example and see for this. So I said positive oxidation state increases means electronegativity increases. Suppose if I have A +1 or A +2, so which will be more electronegative? Tell me. Here, this one, isn't it? More positive oxidation state, this one. So A will be less electronegative than A positive. A positive will be less electronegative than A +2. So you should remember, as the positive oxidation state increases, the electronegativity means this will be more electronegative compared to this. Done. I'm clear, students? Yes. Now let us write one more important thing in terms of negative oxidation states. Now I have written positive increases means electronegativity increases. The other way, as negative oxidation state increases. So I'm taking now negative oxidation state. So what will happen? Electronegativity also, okay, a positive oxidation state increases, electronegativity decreases. Remember, so in the earlier one it was directly related, here this is indirectly related, isn't it? So let me move my board a little bit this side. Okay, so as a negative oxidation state increases, the electronegativity decreases means, how can I take an example for this? Suppose if I have now B -1, B -2, one particular negative oxidation state element does that. If I take one more example, water is here, H2O2 is here, OF2 is here. Now if I have to write the oxidation, negative oxidation state here, oxygen is -2. In this case, in hydrogen peroxide, if I have to write, this is -1. In peroxides, hydrogen valency is -1, isn't it? Right. Now in this OF2, the oxidation state is +2. Right. Now when I have to see the electronegativity among all these, which will be more? As I said, as the oxidation state increases, electronegativity decreases. That means here there is no oxidation state. So this will be greater in electronegativity. This also will be greater in electronegativity. This is one example which you need to remember. Now, in this case, if I have to see, the negative oxidation state is more in which one? Yes students. So here this is -2, this is -1, this is +2. So which case it will have the lesser electronegativity? Yes, this one. So lesser electronegativity. So please understand this concept. As the negative oxidation state increases, electronegativity decreases. So wherever there is more negative oxidation state, that there the electronegativity will be less. Yes students. So this will have less electronegativity, this also will have less electronegativity. So please understand this. Hope it is clear to you all what I explained. Now let's come back and do the next, that is the 7th trick, which is very important for you. Okay, so now in the 7th trick, when I do, that is the thing, right? Here you need to remember one more important thing in terms of S character and electronegativity. Now, as percentage of S character, right? S character we have studied in which one? In hybridization, isn't it? So in this percentage of S character, if it increases, suppose, right? So in terms of electronegativity, what should you remember? As a percentage of S character increases, the electronegativity also increases. That means if I have to take SP, if I have to take SP2, if I have to take SP3, here the S character is 50%. Here the SP2 character, in SP2 S character is 33.33%. Here the S characters are much 25%. Correct? Now among all these, which will have higher electronegativity? I said S character should be maximum. S character is maximum in this. Yes. So SP will have more electronegativity than SP2, more electronegativity than SP3. Right. So this is what is the concept, student. Remember. Right. If I have to write the 8th trick, let us write the 8th trick and see. Right. In the 8th trick, remember, I am writing in a trick related to melting point and electronegativity. Okay. Sorry, melting point and metallic property and electronegativity. Remember, metallic properties are inversely related to electronegativity. That means the ability to donate electrons is inversely related to electronegativity. Remember, if the electronegativity is more, suppose if the high electronegativity of the element, the metallic property will be less, means ability to donate is less, right? Indirectly, if I have to write the 9th trick, remember, non-metallic properties, right? If they are directly related to electronegativity. Remember these students, important. Both the things I have written together so that it is a comparison. Metallic property is inversely related to electronegativity and non-metallic property is directly related to electronegativity. That is a concept, right? Let me erase this. Now let us come and do the 10th trick. Right. So here in the 10th trick, I'm going to talk about nature of hydrides. So let me give you an information about nature of hydrides. Right. Let us write nature of hydrides. You know what a hydrides, isn't it? So hydrides are what, like, you know, NaH. If it's a metal with an hydrogen atom, okay, NaH is one, or non-metal with hydrogen atom, NH3, CH4, those are metal hydrides. So if I have to see the nature of hydrides, right? Now nature of hydrides we'll see, nature of hydroxides also we'll see. So in this nature of hydrides, you need to remember concepts. What is the electronegativity of the central atom? Okay, we will see what are central atoms. So here you need to remember, if the electronegativity of the central atom increases, right? So delta, that is the electronegativity of the metal hydride, decreases. So if the central atom electronegativity, you need to check. I'll write the examples now. So electronegativity of this one decreases. Now because of this, what is happening? Bond polarity. Okay, bond polarity is the what is important here. So bond polarity of the metal hydride, what will happen? It will increase because the bond polarizing into positive and negative ion, it increases, and when it increases, it can easily give out the H plus ion, isn't it? So acidic strength of that particular bond, also increases. So remember this, so much information I have given you. So let us take one example and see this. So note it, electronegativity of the central atom in the metal hydrides, if it increases, automatically the electronegativity, the difference of metal hydride and this one decreases, and when this decreases, polarity also increases. When the polarity increases, I can easily give out and it will become more H. I mean the H plus can be easily donated in the hydride, right student? Now this is in which case? This happens in case of a period. So here this is a trend in the period. For example, if I have to take an example, see here, CH4 is less than NH3, it is less than H2O. So you're able to see this, students, it's clear. Now what is this? Carbon, nitrogen, oxygen, it's going in the period only, like this, isn't it? So this is atomic number 6, the carbon atomic number is here 6, so it is a period. Again nitrogen atomic number 7, here oxygen atomic number 8. So I'm going in a period. This is what is a trend, right? Now suppose if I have to take the nature of hydrides in terms of a group, let us take that. Let us erase this and write nature of hydride as the 11th trick in a group. So we have written in a period, isn't it? Now in a group we will see. So in a group means, suppose example, fluorine, chlorine, bromine and iodine. This is the group from top to bottom. Here in this case, remember, as the size of central atom, if it is increasing, when we go from top to bottom in a period, as the size of the central atom is increasing. Yes students, it's clear? Yes, when it is increasing, the bond length, what will happen? The bond length, whatever is there, bond length of which bond? MH bond. So this bond length among a metal and hydrogen, what will happen? It will also increase. When it increases, H plus, it can lose easily, isn't it? So acidity increases. So when the bond length increases, the distance is more, so I can easily release out the H plus. So the acidity also increases. Remember, this is the trick. So as we know, size increases means acidic strength also increases in metal hydride. Metal hydride is nothing but metal and hydrogen. See here, we have done in the example CH4 and H3 like that. Yes, right. Now let us see one more trick, that is trick number 12 with nature of hydroxides. Okay, let me take out this and write the next one, nature of hydroxides. Okay, so hydroxides, this trick would be trick number 12. Okay, so in hydroxides means nothing. Suppose example, let me take an examples of this. Now see here, ClOH. So this is chloride with OH. Okay, hydroxides. Okay, and next one, nature of oxides also. Both the trends I'll be taking. So let me put the wire properly for you all. Okay, so ClOH is 1, BrOH is 1, IOH is 1. So these are all metal hydroxides, or not metal, these are non-metal hydroxides. Just I am talking about hydroxide nature. Next, if I have to speak about oxides, now I'm going to take magnesium oxide, calcium oxide, strontium oxide and barium oxide. Now remember students, here if I have to speak in terms of acidic strength, so what should you remember? Remember, acidic strength of hydroxides on oxides, okay, is directly related to electronegativity of central atom. Okay, what should you remember? The acidic strength, if I am clear, I think I am writing this. So acidic strength of what should we write? Yes, so as I said, acidic strength of which one? Of oxides as well as hydroxides. It is directly related to which one? Acidic strength is directly related to electronegativity of central atom. So here if I have to justify this statement, electronegativity of central atom, justification means, so among all these, if I have to see which one is greater, acidic strength will be greater for what? Which has more electronegativity in chlorine, bromine and iodine? Chlorine, isn't it? So this will have more acidic acidic strength. Bromine, isn't it? Bromine will have more acidic strength. If I have to compare this, magnesium oxide will have more acidic strength, calcium oxide will have more acidic strength, strontium oxide will have more acidic strength. So what is the comparison? So you need to see whichever has more electronegativity of the central atom. This is central atom. So for that one, you need to see the acidic strength will be more for that. Okay. Yes, students, this is clear, I think. This is trick number 12. Let us do one more trick, that is trick number 13. Now, gradually I'm taking you into the different concepts. Right. So when we speak about trick number 13, atomic density. So atomic density, if I have to speak, if this question is given to you, what should you remember in the exam? Remember, we know density. Okay, let us write the formula for this. First, density is equal to mass by volume. Correct? This is what we have written. Right. So here, this is simple formula that is not required for us. Let us see. As the atomic mass, density is equal to mass by volume. Now I am speaking in terms of mass. As a mass increases, right? Yes, students. Next, this atomic mass increases in which in a group, from like we're talking in terms of a group. So this is in a group. So what is happening here? Mass is greater than volume, because both are in a group. What is happening? As atomic number increases, the atomic mass also increases, isn't it? Because the number of shells increases. So when the mass is increasing, automatically, means mass by volume is there, both are, one is increasing, one is decreasing. So mass will be more, volume will be less. So what will happen? So atomic density also, okay, let me write atomic density, yes, increases. So why did I write? We have written just now, density is equal to mass by volume. So when the mass is more in a group, atomic density also is more, isn't it? Right. This is the trick, students. Now let us erase the 13th trick and come to the 14th trick. Right. So in the 14th trick, if I have to speak, I am giving you a trick in terms of melting point and boiling point. Yes, students. So note it, melting point and boiling point. How do we do this? So in the 14th trick, if I have to speak, melting and boiling point, remember the trends of melting point and boiling point. Okay. Now here, for in a period, if I have to take, so let me write in a period and in a group. So if I have to see the trends of this in a period, remember S block has greater than melting point, boiling point than D, then P. This is the trend. If I have to write in terms of groups, S block elements, it is, let me write neatly, S block elements in a group, if I am talking in terms of melting and boiling point, S block element, it decreases. Again in D block element, it increases. Remember this trend. And one more thing you need to remember, that is, let me erase this. Okay, hope you have noted this. Next important thing you need to remember, in group 13 elements and group 14 elements, 13 and 14 elements, the melting and boiling point decreases. You need to remember all these terms during exams, right? Again, if it is group 15 and 18, the melting and boiling point increases. So this is a very important trick you need to remember in the exam. If they give you melting point and boiling point trick, it should be easy for you to answer this. Okay, right. So after the 14th trick, right, students, now let's come back and do the 14th trick, that is your I think last was the 14th trick. Let me come and do the 15th trick now for you, that is ionic mobility. So here let's see the concept ionic mobility. So what is the trick I need to remember in ionic mobility? So first thing you need to remember, ionic mobility, I am writing in shortcut, ionic mobility is inversely related to the size of ion in aqueous medium. Size of ion in aqueous medium. Let us see one example for this and understand. So here basically in ionic mobility is the movement of the ions. Those are formed in the aqueous solution, isn't it? Right. Suppose if they have given me an order in aqueous medium, they have given me certain ions. Now I said if the size of the ion is smaller, the ionic mobility will be more. The reverse way, if the size of the ion is larger, the ionic mobility will be less. Correct? Now suppose if they have given me lithium plus, cation, sodium plus cation and potassium plus cation. So all are the ions formed in the aqueous medium. Now you only tell me, students, among all these, which is bigger cation? When we move from left to right, the atomic size decreases, isn't it? Or the ion here, among all these three, the potassium ion is larger in size compared to lithium. Now among all these, which will have more ionic mobility? The smaller one. So whichever, okay, indirectly we'll say, the smaller the size of the ion, the ionic mobility will be more. See here, inversely related. So lithium will be more or having more ionic mobility than sodium will have more ionic mobility than potassium. Simple, isn't it? Right. So let us come and do the next trick. Now when I have to speak in terms of D block, I'm giving you a trick in terms of lanthanides. Now let us erase this and take it. Now when we speak about the F block elements, that is lanthanides. Now in lanthanides, remember, this is the next trick. So in lanthanides, now, okay, so here what is happening, as we studied about lanthanide contraction, isn't it? Right. So I did a video also, please watch. Now remember, as the atomic number increases, most important thing, radius decreases. If you remember this, the whole concept of lanthanide contraction, you will understand. So as we go from lanthanum, so gradually as atomic number is increasing, radius automatically decreases because of the ineffective shielding. That is, you have studied lanthanide contraction concept, please watch that video. So remember this, right? Now the same thing, if I have to speak in terms, if I have to take the 17th trick and talk to you, right? In the 17th trick, again I'm talking or giving you a trick based on ionic character. Okay, so ionic character, if I have to take, always remember ionic character. Okay, let me write little bit this side, students, so that it is enough for me. I have handwriting, very big handwriting, isn't it? Okay, so ionic character, if I have to take, it is always indirectly related to polarizing power of cation. So polarizing power of cation, polarizing power of cation. Now how can I see this? How can I justify this? So indirectly related, let us take one example and learn, right? So here, suppose if I have to speak or give you the ease with which they are liquefied, like in the next concept. So here ionic, remember this. So ionic character, I think we have studied this concept in the Fajan's rule also. I did one video for this, you can also watch that video. Now suppose if I have to take the ease of liquefaction in terms of inert gas elements. Now I'm going to do the 18th trick for you for inert gases, right? So this is for inert gases. In any inert gas question is given to you, you can take this. If they ask you what is the ease of liquefaction of the following, remember one trick: ease of liquefaction. Ease of liquefaction is always directly related to intermolecular bonding. Intermolecular bonding. So we very well know in case of inert gases, if I have to take, which can I do or which can I easily liquefy, whichever intermolecular bonding is more, both are directly related, right? So xenon is greater than krypton, greater than argon, greater than neon, greater than helium. So this is the order, students. So here the intermolecular bonding is more, so you can easily do the liquefaction part. This is one concept. Now let us do one more in terms of trick number 19. Let me take out this. So here in trick number 19, remember covalent character. Again I have given one ionic character. Now I'm going to give you in terms of covalent character. So remember ionic character, what did we say? We said ionic character is inversely related to the polarizing power of cation. Now if it is covalent character, it is directly related to the polarizing power. So that inversely related, this is directly related to the polarizing power of cation. Okay, polarizing power of cation. So always remember ionic character, if they give you, you need to remember which is more. If they ask you which has more polarizing power, so polarizing power of cation and ionic character, both are inversely related. covalent character and polarizing power, both are directly related. This is clear, students? Right. Now let us write one more trick, that is trick number 20, based on your degree of hydration. So a trick based on degree of hydration. Okay, right. Now see here, always remember, if they ask you a question based on degree of hydration, simple thing you need to remember, smaller the cation, greater is the degree of hydration. So I remember this in the exam, smaller the cation, the size of the cation is smaller, then automatically the degree of hydration. So smaller the cation, what should you say? Greater is the degree of hydration. So the degree of hydration part is more for which one? If the cation is smaller. Let us take one example. Suppose if I take in terms of S block elements. Okay, so in S block smaller cations are there, isn't it? Because the atomic number is small. So which will have degree of hydration higher? Lithium. Lithium will have maximum, or lithium cation will have more degree of hydration because the cation is smaller. So lithium will be greater than Na plus. Na plus will be greater than potassium plus, which will be greater than rubidium plus. So which will be greater than cesium plus. Simple, isn't it? So remember, if somebody asks you to solve the degree of hydration question, you need to say, if the cation is smaller, degree of hydration will also be smaller in case. This is the thing in S block, right, students? Now, suppose if I have to write in terms of your P block, or not P block, in alkaline earth metals. This is alkali earth metals. Now, if I have to write the trend in alkaline earth metals, what will I write? The first one. So, the first one, earlier we have written lithium, isn't it? Now, let us write for beryllium. So, beryllium plus 2 will be greater than magnesium plus 2, which is greater than calcium plus 2, which is greater than strontium plus 2, then barium plus 2. So based on this concept, I have justified that this should be there. So among these, the degree of hydration will be more for or greater for beryllium because of its smaller size. Now let us come and write the 21st trick, that is boiling point trick. So trick based on boiling point. So in boiling point in inert gases. So remember, this is the trick for boiling point in inert gases. Always remember order of boiling point, right? So order of boiling point is for inert gases, helium is less than neon, less than krypton, less than xenon. So this is the order of boiling point for in terms of inert gases. If they give you in the exam, so boiling point, so don't get confused. This is a order trick. Directly you can write this order and finish up, because they may ask you in the inert gas is given which one is more. So this is the order. You can directly remember and write. Now let us come and meet with the 22nd trick. Right, students. Now in the 22nd trick, let us talk the trick based on atomic density. So density questions will be given to you. Always remember this as an exception, important. So basically, if I see the atomic density, S block elements, atomic density will be less than D block element, which will be more than P block element. Remember this. So when I speak in terms of density trends, this is what you need to remember. And there are certain exceptions here. So the exceptions will be, in this case, sodium will be greater than potassium and magnesium will be greater than calcium. Remember, so this is where they're going to ask you. So if you know this, this is the concept, but these are the exceptions which you have in terms of atomic density. Right, now let us do the 23rd trick. So very interesting, isn't it? Right, so in the 23rd trick, we are going to discuss an exception in terms of atomic radius. Right, so here I am writing the exception in terms of atomic radius. So what is that exception? Remember, students, here 4D series, as you know, 4D series is almost approximately equal to 5D series. Why? What is the concept here? Here because of lanthanide contraction. So because of the lanthanide contraction, you are going to see, or the atomic radius is almost approximately equal to 5D series because of this contraction which happens in that. So this is in the D block, right? If I have to see an exception in the P block elements, remember aluminium has, this is an exception, aluminium has greater atomic radius than gallium. Lithium plus ion has a greater than magnesium plus 2, and H minus has greater atomic radii than F minus. So these are the exceptions. Remember, because exceptions is what they're going to ask you. So I have written in this case. So this is the atomic radius. Now if I have to speak the exception in case of ionization enthalpy, right? So let us take that. So right. So in the 24th trick, exceptions in ionization enthalpy. IE means ionization enthalpy. Remember students. So here if I have to speak in terms of the D block elements, again 4D here is less than 5D. Why? Because of lanthanide contraction. And what is happening here, the Z effective or the effective nuclear charge is very high in this case. Because of this contraction, the nucleus pulls the charge, this one, near closer to the nucleus, ineffective shielding. That's why 4D ionization energy is less than 5D. Now certain exceptions if you take like this, zirconium is less than hafnium, palladium ionization energy is less than platinum, yttrium is less than lanthanum, right? Here why it is greater, why yttrium is greater? Because there is no lanthanide contraction here. Remember that. So this is in terms of your exceptions in ionization enthalpy. Now the 25th trick which we are going to see in this case, let me erase this 25th trick, right students? So here I am going to do an exception in terms of your exceptions in terms of your D block and P block, and that too in terms of electronegativity. So till now we did atomic radius, then I have taught you density. First I have taught you density, then I have taught you in terms of atomic radius, then I have given ionization enthalpy. Now I am giving you electronegativity. So right, so remember as an exception, aluminium has less electronegativity because then gallium because of high Z effective. So the Z effective is high means automatically the exception is shown in this. And because of the electronic configurations, if you write and see, you can understand this. And in the 4D is less than 5D. The reason is the same. Z effective is very high in this case, that's why. And if I have to see the D block element, zirconium is less than hafnium. Okay, yttrium again is greater than lanthanum. Why? What is the reason in this case? Here there is no lanthanide contraction. Remember. So why I have given these trends like this? Because these are the exceptions which they ask you in exam. Okay, right. Now if I have to see the P block elements in the exception case only, if I have to write in terms of P block, I'll erase this. Remember, in terms of P block, the exceptions which are seen, I have written only exceptions students. Indium is less than tellurium, tin is less than lead. So please note it. So this is how, you know, almost it took a lot of time for me to compile everything students. So these are the 25 important tricks for you all. I have done a 50 trick series also. It's a super hit actually because of you all. Now these are the 25 tricks from my side. Thank you for watching. I am again writing. Please watch which one. Now I have 2 tricks, that is your 50 tricks in inorganic chemistry as well as 25 tricks in inorganic chemistry, top 25 tricks in inorganic chemistry. Please make this as a hit also. Thank you for watching 50 tricks, and I'll meet you again very soon. Please use this for your JEE as well as NEET. Thank you for watching. Stay happy, stay connected.